This is Roger Sheeker, Chief Engineer of Audience, who is going to help us understand today something that Audience has asserted for a long time, which is the detrimental effect that eddy currents have in audio cables. Roger, can you help us out?
Yes, John. Eddy currents named after the phenomenon we see along streams where water is flowing and the currents along the banks are going into a swirling pattern called eddy currents. Well, much the same phenomenon occurs when there's a magnetic field interacting with a conducting material. Of course, we can't see that and we have to visualize it in our minds, but this is indeed what happens. This phenomenon is created by magnetic energy, which in turn is created by the electrical signal going through the conductor. This electrical signal has an associated magnetic field around it. This magnetic field radiates out and impacts into the surrounding materials, be they insulators or conductors. When this magnetic field enters a conducting material, it creates a current. This current in turn creates an opposing magnetic field that tends to retard the motion of the original signal. And this can very clearly be demonstrated with a magnet, in this case about a 3-pound magnet, and a conductor, in this case a piece of copper tubing. Now, in order to make the magnetic energy create a current here, we'll drop the magnet into the tube. As can be seen, the magnet motion is greatly retarded, taking some 3 seconds to transition this 1 foot of length. This is due to the opposing magnetic fields being generated by the eddy currents. Now, this is a relatively thin piece of copper tubing, but if we have a real heavy conductor, copper, like this tube here, it'll create far more eddy currents due to the mass. Let me show you, let me demonstrate what happens in this case. As can be seen, it moves extremely slowly because this is the creation of really powerful eddy currents within this copper.
So you're saying that the mass of the conductor itself creates more eddy currents or eddy current resistance?
More eddy current resistance because of the mass, because of the conductivity of the copper. And just the fact that there's more material there for the magnetic energy, the fields, to interact with.
So then how do you bring that back to an audio cable?
By having less mass, you have less interference with the propagation of the audio signal because of less eddy currents. Eddy currents interfere with the propagation of the signal. They actually convert some of the signal's energy into heat. Once this occurs, that energy is lost and gone forever and cannot be recovered. It's been transformed. Same effect we have here, although we can't measure the amount of heat being generated because it's so small.
So this would be a case of less is more?
Absolutely. And the design for low eddy currents improves the signal propagation through the cables and improves the level of distortion. It reduces it significantly.
All right, very good. Thank you very much.
You're entirely welcome.